Hello everyone and welcome to CCNA Scaling Networks version 6. Today we're looking at chapter 9, Multiarea OSPF. So what we're going to look at, why we need multi-area, the differences in the link state advertisements, the differences in the neighbor adjacencies, how to configure multi-area for version 2, IPv4, how to configure multi-area for version 3, IPv6, and summarization, and then a bit of verification at the end. So, single area OSPF, awesome, love it, fantastic, wonderful. However, once your network gets a little bit big, things start to go wrong. There's a poor router in the bottom left who's running out of RAM because the route table is too large. Router 1's getting way too many link state advertisements. Router 2 is constantly rerunning the open shortest path first algorithm. And there's just too much going on, and these guys are really struggling because the network is just too big. Solution: areas. Exactly the same physical routers, but now we've got them in little pockets. So now in area 1, that router only needs the routes for the networks inside area 1 and how to leave area 1. It doesn't need any more. So the size of his routing table has just shrunk dramatically. The R1 is now only touching area 1 and area 0. So it's not fussed about all the nonsense that's going on in area 51. Similarly, router 2 only cares about area 0 and area 51. So any nonsense that happens in area 1 is completely protected, it's isolated. Smaller route tables, less RAM, less computing. This is the benefit that multi-area can give us. So, but there's a hierarchy. You always have to have area 0. You always have to have area 0, and all areas must touch area 0. Or if you want to do more advanced, they must at least know their way to be able to find area 0. So the backbone area, or area 0, all areas, or area 0 must exist, and all other areas must be able to touch area 0. So that's the backbone area. Any other area that isn't 0, just a regular area, just a normal area where routers can live and survive and do their thing. So let's have a look at some terminology. The first one is an internal router. An internal router is a router where all of its interfaces live in the same area, or a single area. So all of the routers that are highlighted in orange, all of their interfaces exist in one area, an internal router. A backbone router is all routers that have at least one interface in area 0. So R1 and R2, they're special because they are both backbone routers and something else. Which also the other two routers in area 0, they're internal routers and they're backbone routers because they're internal to area 0 and they live in the backbone. So a backbone router must have at least one interface in area 0. An area border router is the border between two areas. So an area border router is a router that has at least an interface in two different areas. So router 1 has got an interface in area 1 and area 0, and router 2 has got an interface in area 0 and in area 51. So they're an area border router. The last one is an autonomous system boundary router. Now this router, router 1, is the only router in this whole topology that is doing something that's not pure OSPF. It has a connection to the public internet. It could be a static route or some other routing protocol, but it's not pure OSPF. So therefore it's the boundary of OSPF. As far as OSPF is concerned, this is the way out of all things OSPF. So therefore it's the autonomous system boundary router. At least one interface in a non-OSPF area. So link state advertisements. Remember last class we looked at the 5 types of packets? Well, LSAs was one of those types, and there are 7 different types of LSAs. So let's have a look at them. The first one and the second one, type 1s and type 2s, they exist inside the same area. So type 1s are generated by the routers, and type 2s represent the networks themselves, and they're represented by an O for OSPF. So type 1s and 2s exist inside a single area. Type 3s and 4s are exactly the same as the 1s and 2s, but they only can be made by ABRs, and they're generated by their information about other areas. So 1s and 2s are information about the area you're in. 3s and 4s come from ABRs about different areas. Type 5s are external, and type 5s can only be generated by an ASBR, an autonomous system boundary router, and they describe destinations outside of OSPF. Now there is a type 6 and there is a type 7, but we don't talk about NNSA in CCNA anymore at all. It's more of a CCNP type topology. So to quickly sum up, there are 5 types you need to worry about and 3 broad categories. 1s and 2s, inside an area. 3s and 4s, from another area. 5s, external to OSPF. Let's have a look at that in practice. So we've got the route table of this lovely router here. All of the O's represent OSPF. You see that the light fawn down the bottom here is represented of a pure OSPF entry. So, and this one up here as well, 10.2.1.0. Then the purple in the middle are represented of networks that are pure OSPF, but they're in a different area. And then way at the top here, we have the orange. It's got an E2 and it's got a little asterisk. So this will be a static route that's been redistributed into OSPF. So it's external to the OSPF process, and it's got the asterisk, and the asterisk represents our default route. So O, same area as U. IA, different area, but still pure OSPF. E, show IPv6, thankfully exactly the same. All they've done is they've just changed, they've dropped the A for some reason. So your O's, pure OSPF. The purple, it's OI, so it's the same as inter area, exactly the same. And the E2 is external to OSPF. Now the thing about route calculation, this is the type 1s and 2s, 3s and 4s and 5s, there is a hierarchy involved. So what this slide is trying to say, and not doing a very good job, is that routes learned from inside your area are the best. You can't beat that. A static route or an external route or even a route from another area will not be able to beat information that you have learnt yourself. 3s and 4s are the next. So if you've got a bunch of 3s and 4s coming in, that's information about another area. So that's the second best in priority. Now the final one is external. So if you've got a route to an external source or an inter-area route is learnt to the same source, then the inter-area route will survive. But if the external routes is the only one of that kind, then that's the one that's going to be in your route table. So 1s and 2s are the best, 3s and 4s are the second best, 5s are the third best. So if any of them are the same as another, that's what will survive. 1s and 2s beat 3s and 4s, 3s and 4s beat type 5s. Multiarea OSPF needs a bit of thinking, a bit of thought. You can't just throw it together and hope for the best. You need to pick some strong, beefy routers with good CPU and RAM and you want them to be your designated routers and to be in area 0, and you want the routers on your ABRs to also have a bit of guts in them as well. But let's have a look at how we're going to put this stuff together. So here's a good example. Multi-area configuring multi-area. So we've exactly the same as what we were doing before. We've got our routing process. We set up a router ID manually, didn't have to, but we did it anyway because we wanted to. And we've got 10.1.1.1, all zeros is area 1, 10.1.2.1, all zeros area 1, and 192.168.10.1, all area 0. So this router here has got these two networks in area 1, and this is all of area 0. Now, this is just an example. For some reason, the person who put the slide together decided that it would be a good idea to make these just host addresses. So technically speaking, on the route table of R2, if you were to ping 10.1.1.100, it would go nowhere, because we're only just advertising this one address. So in the real world, in a practical world, I would have made these 245. So 10.1.1.1.0.0.0.245, 10.1.2.1.0.0.0.245, and 192.168.10.1 0.0.0.3, because that's the /30. And that would have been a better indication of what it is. But this is how simple it is to set up multi-area. You just say what networks they are and which area they're a part of. IPv6, exactly the same philosophy. Remember that IPv4 has network statements, and IPv6, you put the information in the interface itself. So here we've set up the router ID, always got to do that. And then gigabit 0 is in area 1, and serial 0 is in area 0. That's it. Just remember that this number 10 here for the router process has to match this area 10 in this router process the same. The reason why this is done is because technically, yes, you can have multiple instances of separate OSPF running, but I wouldn't recommend it. Now, summarization. The reason why we have areas is to keep the topology databases as small as possible. So when router 1A, he might have 20 networks in there, and we can summarize all of those networks into a single entry. So router 1 says, you know what, I got 20 networks underneath me here, so I'm going to send you a summary up to here. So R1 doesn't advertise 20 networks, he just advertises a summary, and that summary is a type 3. So it goes up here into area 0, and that type 3 is summarized. So all of these guys have IAs for all 20 of these networks, just summarized with a single line. So, however, this is the big thing that a lot of people seem to not understand when they're doing the labs. R1A is always going to see 20 networks. R1 is also going to see 20 networks. Why? Because those 20 networks are going to be type 1s and 2s. And remember, R1 is in area 1, so therefore it has to see all the networks that exist in area 1. But the summary is heading up this way, so as it goes through the ABR, the summary is a type 3. So therefore C1 sees the summary. R2, R2A, R3 and R3A all see the summaries. But when you're trying to do a summarization with OSPF, remember, all routers within the area you're in will always see all networks. They can't not. You got 20 networks down here, router 1 is going to see those 20 networks because they're in the same area. All routers in the same area must know everything about everything in that area. So your summary is going to go through R1, and then R1 will summarize to C1. So C1 will only see one entry. R2 and R2A, 3 and 3A will only see one entry. But just remember that R1 will always see all 20 networks. It's C1 where you want that summary to exist. And that's why your ABRs need to be a little bit beefy. Now, why do we summarize? When links fail. So let's say in here in area 1, we've got 20 networks and one of them's a bit dodgy and it just flaps up, down, up, down, up, down, up, down. Well, all of those up, down flaps are going to exist here. So this router is going to have to do lots of processing. R1's going to have to do lots of processing. Flap, 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 flap. But none of those flaps are going to get out. Because C1, R2 and R3, R2A and R3A, they only see the summary. They don't see the fault in the network at all. They're protected by the ABR, and that's another. External routes summarized exactly the same way. This example, we've got ERGRP, and we've got 32 networks that we have summarized. So we set up a summarize, and we inject that into the ASBR as a single summary. So now router 2 sees all those networks, but router 1 and router 3 only see a single E2 summary of all of those networks. Remember, the goal of routing is to have our route table as small as possible. A small route table is a happy router. So, how do we do summarization? So, this example, we have got 192, 168, 64, 65, 66, and 67. We've got 4 networks in area 2 that are contiguous. We can summarize those with a single line. But just for fun, just to keep you on your toes, there are 2 different commands. So if you're on an ABR, then you need to use the range command. Area to range and then the address. If you're on an ASBR, then you have to use the summary address command. Now, notice that these are in the routing process. So this is just telling the router, by the way, when you tell everyone else about this information, tell them this as well. So when this hits the ABR, it'll summarize those 4 links into one. And this one comes from an ASBR. It says, guys, this is a summary address. So ABR's range command, ASBR summary address command. 2 different commands to do the same function, but on 2 different types of routers. So, how do we verify and test that everything's going fine? Show IP OSPF neighbor, show IP OSPF, show IP OSPF interface, super duper useful commands. Because show IP OSPF interface tells you what area you're in and all that sort of stuff. Show IP protocols, really, really useful. How many areas you've got, which networks are being advertised. Show IP OSPF interface brief, very useful. And show IP route OSPF just shows you OSPF routes. And show IP OSPF database is going to show you everything about what OSPF knows about that network. And like all good show IP commands, if you're doing IPv6, just change IP for IPv6. Show IPv6 protocols. Show IPv6 OSPF database. Exactly the same. So, good example here. Show IP protocols. Number of routers in this area. Number of areas on this router, 2. It's got 2 normal areas. It's got 10.1.1, area 1, 10.1.2 in area 1, and 192.168.10 in area 0. Down the bottom here, we've got show IP OSPF interface brief. Show. It's got 3 interfaces. The process ID is 10. Serial 0 is in area 0. Gigabit 1 and 0 in area 1, and their addresses and all that sort of stuff. Notice that the serial, the state, comes up as a point-to-point, and the other 2 come up as a designated router. And you got the cost in there as well. Notice, there you go. Here's a perfect example of the person building these slides forgot to set the auto cost reference bandwidth. Because notice the cost of those gigabit interfaces are 1. If you set the auto cost reference bandwidth, it should have been a higher number. Verification IPv6, same as before. Show IPv6 protocols. We've got the router ID, we've got 2 normal areas. Area 0 has got serial, area 1 has got gigabit. Show IPv6 OSPF interface brief, exactly the same thing. 00 is in area 0, gigabit 0 is in area 1. So, multi-area, it's not as scary as you think because it's all about just putting in the area command at the end of your network statements, or in IPv6 the different area commands. But you've got to know why and where to use them. And when you summarize, remember use the range command for ABRs and the summary address for ASBRs. So, terminology, 4 different types of routers. Internal, all interfaces in the same area. Backbone, at least one interface in area 0. ABR, at least one interface in 2 different areas. ASBR, non-pure OSPF. And area 0 must exist. Type 1s and 2s are in the same area. Type 3s and 4s are between areas by ABRs. Type 5s are about external, things that are non-pure OSPF. Shortest path first tree is used to determine the best path. And when you look at the route table, OSPF is O. OSPF into area, your 3s and 4s, they're an IA. OSPF type 5s for externals are marked with an E. Useful commands, show up your OSPF neighbor, very useful. Show up your OSPF, show OSPF interface, show up your protocols, all super duper useful commands. And if you want same commands for IPv6, just swap IPv6. So you can almost, you almost don't need to write them down because you just know that if you're doing IP, show IP OSPF. Doing IPv6, show IPv6 OSPF. Exactly the same command. Alright, thanks very much for watching, and we'll see you in the next one.